going to talk about polar graphing. We're going to graph this by hand. R equals 6 sine of 3 theta. Before we do that, we need to understand what r and theta are. R is kind of like the x coordinate. Theta is like the y coordinate. You know what? Yeah, why don't you put it on there? And I'm going to give these back to you after I grade them so that you can study them. Okay? But it's a little bit different right here. We usually put a number in for, you know how usually in equations we put a number in for x and we get y? This one we're going to put a number in for theta, and then we're going to get r, usually is how it goes. But let me just give you an example of a point that you guys are going to use right here. 3, 40 degrees. Okay? Now, what you're going to do to graph in polar coordinates, this is not hard, if you're listening, okay? You're going to go to, we can go to r first, and we can go to 3. What r is it's the distance away from what we call the pole. This is called the pole. Like the North Pole or the South Pole of the Earth, right? Okay, so that's kind of like the pole. And then each one of these red lines right here is a unit away. It's a circle with a radius. Like this right here is a circle with a radius of 1. Then this circle has a radius of what, you guys? 2. Okay? And then this circle has a radius of 3. It's 3 units. It's 1, 2, 3 units away from the pole. So what's the radius of the largest circle on here? 6. Okay, this is 4, 5, and 6 right there. Okay, so that's what that is. Okay, then these lines that are going out this way. Now, by the way, your graphing paper is different than what I have on here. I didn't get to choose what I have on here. Okay, but on there, notice yours goes every 10 degrees. So your first line is a 10-degree line. Mine happens to be a 15-degree line, and then a 30-degree line. It goes every 30 degrees. Then a 45-degree line. Then a 60-degree line, 75-degree line, and 90 degrees, just like any going around any circle, right? It starts with 0 degrees right here off to the right. Okay? So when you graph the point 3, 40 degrees, where is that going to be? Okay, go find it on your piece of paper and put it. Mark the point. On mine, it's going to be about right. 40 degrees is about right here somewhere, and that's 3. So that's 3, 40 degrees for me. Okay? Let's graph this point right here. 2, 45 degrees. But you can know about where it is, can't you? Okay, so 2, 45 degrees would be right here. Okay, then, see, it's not hard, is it? All right. Okay, graph, let's go these two. 0, 60 degrees and 0, 70 degrees. Graph those two. You can graph them at the same time if you want. It's the same point, isn't it? Where is that point? Yeah. Since the radius is 0, it's right there at the pole, right? Okay. Graph 4, 60 degrees and 4, 70 degrees. 4, 60 degrees and 4, 70 degrees. Here's 4, 60, and here's 4, 70. 70, about right there, right? 4 comma 60, 4 comma 70 degrees, right? Okay, any questions so far? Well, in mathematics, graphing in a rectangular coordinate system like we normally do is not always the best way to graph something or to come up with a model that will model something in the real world. And so, well, some time ago, someone decided to create a different way of graphing, and they came up with a polar graphing system where you use a distance away from the center and an angle that you're going to turn to get that. Okay, so this came about a long time ago. And you know, I was teaching this class, the pre-calculus class, I don't know, 12 years ago or so. I think I told you about this kid named Daryl Wasden, and he's graduating from the University of Utah with uh, a PhD in mathematics now. And he liked to do computer programming, and he would when I started teaching him about polar graphing, he thought it was the coolest thing in the world because all of a sudden the animations that he was using on his computer graphing went from being hard and difficult to do in the rectangular coordinate system to being really easy for him to do. Yeah, he never did his homework very often, but well, I shouldn't say he never did his homework. He did it just enough to get by, and he always aced my tests. But he was fascinated. Every day I would teach in class, he was fascinated by everything I taught. He would ask lots of questions. It was always a really good class because he was always asking really good questions. Because he wanted to know how he could use this to do his computer programming. Because everything I taught in that class, he could use in his computer programming. He would take it home and implement it, and that's why he would remember it all. That was better than homework, if you ask me. He was applying it. And yeah, you know what? I did because I felt like that his homework was to apply this stuff in his computer programs, and so that's what he would do. And huh? And he would bring them to me and show them to me all the time. What he would do. So okay. So so anyway, he did that kind of stuff, but he all of a sudden his animation became a lot easier because of polar graphing. So there's just things you can do in polar graphing you can't do in rectangular graphing. Am I an expert on this? By no means, no. And have I ever applied it like that? No, not like Daryl did, but he could do that. Yes. Oh, I'll let you do it at the end of class today. Okay. Yeah. For those of you who wanted to retake it. Okay. Now, you guys, how do I get a point? Okay, I'm going to ask you guys to do this right here. I want you guys to tell me what the coordinates of that point is. Okay. It's 4, 135, right? Okay. Tell me what point this one is. 650. 150. Yeah, if that's 135, this is 15 degrees more, right? Because mine are going up at 15 degrees. So it's 150. Yeah, I think Eric's got this down. Okay. Name this point right here. Well, Jay's got one part of this down. 165. Well, this is 180. That didn't even make it half. 165. Huh? 255? Well, let's see. 180 plus, okay, that would make 30 plus another 30, 60. So that would be 240. 255, is that what you said, Rachel? 255. Okay. Now, did you know that there's more than one way to name a point? And this part you're going to have to listen to really closely, Addie, right here. To name a point, you can use negative r values or negative theta values right here, angle values. So, for instance, if I wanted to get this point right here, I'm going to go to the line opposite of it right here, So what point is that right there? 2 comma 75 degrees, right? So I have 2 comma 75 degrees. Another way to name, and instead of going this way, though, if I want to go the opposite way, I go negative 2 comma 75 degrees. So this point right here can also be called negative 2 comma 75 degrees or 2 comma 255 degrees. They're the same thing. Could it be 2 comma negative 75 degrees? No, because that would be over here. How could I get to it using a negative angle? What is that angle? This is 15 degrees away from the 90, so negative 105, is that what you said? Yeah, 2 comma negative 105. So this point can be called 2 comma negative 105 degrees. That means you turned it to the right because it's a negative angle, and then you went down 2 units. Do you understand that? So the 3 ways to name this point so far is negative 2 comma 75 degrees, 2 comma negative 105 degrees, and 2 comma 255 degrees. There's one more way to name this angle. Can someone come up with it? That's right. Negative 2 comma, no wait, it's not going to be 255. It's going to be 285, negative 285, right? Well, because we know to turn this way is 75 degrees, right? And this is the one that's opposite of that one. So you just minus 75 degrees off of 360, which is 285. So we went 285 degrees around the circle this way. Sorry. We went 285 degrees around the circle this way, and then we went negative 2, so we went back to there. Okay? Negative 285 degrees would be turning in the clockwise direction, 285 degrees, so it would end up on this line right here. And then instead of going out positive 2, we went negative 2, which was in the opposite direction right there. So we had the one where r was negative, and the angle was positive. And this one where r was positive and the angle was negative, and then where they're both positive and then where they're both negative. Does that make sense? So you can there's 4 ways to name every single point. 4 ways to name every single point. Got this, Sydney? Sydney, you can do this. You just didn't see the first part of it. Okay? So I'm going to pull up a new one right here because some of you guys are feeling a little frustrated on it. Okay. Sydney, you ready for this part? You can do this one. Bryce, you ready? Watch this real quick. If I'm going to graph the point, everybody graph this point and then name it in 3 other ways, okay? I want you to graph the point 4 comma 60 degrees. I want you to graph it and then find the other 3 names for that point. Graph the point 4 comma 60 degrees. Four comma 60 degrees. Okay, if you haven't graphed it yet, it's right there because you go up to the 60 degree line. This is the 60 degree line. And you go out 1, 2, 3, 4 units out. And that's 4 comma 60 degrees. Everybody got that? Okay. Then you got to come up with the other names on it. One's going to be where r is negative. So you've got to be on the opposite line of that, Kaylani, right down here. And just make r negative, and then it will go back. So what is the opposite of that line right there? You could name it using a negative angle, yeah, and then a negative r value. Okay, so we could go positive 240 is that angle if you go the opposite, right? How do you know it's positive 240, you guys? What do? You go straight across, but but what number would you add to 60 to get that? 180. Why 180? Yeah. You guys, I'm too close to this to see. Is this the line that's straight across from me? Okay. No, it'd have to be the blue one. Okay, is that the one that's opposite of it? I'm so close to it I can't see it. Okay. So that's the one opposite of it. So, but we don't want this point. I mean, this is the point. This is the point 4 comma 240 degrees, right? But I don't want the point 4 comma 240 degrees. Instead of coming out 4 units this way, I want to go back that way. So what is my point that's the same? Negative 4, 240 degrees. So what we did, for those of you who don't understand that, we went around this thing to 240 degrees. And since we put our value as negative, instead of going out the direction of that angle, we go opposite of that angle, which would put us up there. 240 degrees would be turning clear around to this line right here, right? But instead of going out a positive 240 this direction, whoops, I was on the wrong line, huh? Instead of going out a positive 240, positive would be going out on 240 that way, right? But I want to go negative. I want to go the opposite of that, so I put a negative 4. Because I want to land on this point. That's the point we're talking about, right? Okay. Negative 4 comma 60? Well, 60-degree line is right here. It would put your point right there. Yeah, it would put it the same place as this one right here. Okay? So now we've named it with positive, positive, and negative, positive. How could we do it with positive, negative? In other words, I got to get this negative angle. I got to go this direction to this angle. How do I get to that direction on that angle? 4 comma what? 4 comma negative 300? Well, all I have to do is go to here. So what is that angle? That's negative 90 degrees plus a negative 30 degrees. It's negative 120 degrees, isn't it? What? No, negative 120 degrees. No, because I went negative 120 degrees, and since it's positive, I go out on that line. Oh, yeah, we want to go to that side, don't we? I was starting to think we went to this line. Okay. You're right. I was thinking we were going to this line. So negative 4 comma negative. That's how you do the. I was starting to think we were going to this line down that was down here in the third quadrant, but we wanted to go the opposite of it. So we went. So one more time for those that didn't understand that, we went negative 120 degrees that way. This is the negative 120 degree line, but we didn't want to go out on this line. We wanted to go opposite up to that point right there. So we had to make it negative. So negative 120 degrees, so we turned clockwise, and then we had to go back negative 4 degrees. Okay, now we need the one that's positive 4 and then negative something. Okay, positive 4, negative 300. So we want to go clear around to there. Is it 300? Oh, wait, yeah, negative 300, sorry. Negative 300, that way. Negative 300 degrees, and then go out 4 units on it. So we went 300 degrees around in the clockwise direction, and then we went positive 4 units out, which would put us right on that point right there. So there's the 4 ways to name that point. Now, the best way to teach you guys is to do this graph now. So everybody, what we're going to do, let me get another graph here. We are going to graph, what was that? R equals 6 sine of 3 theta. Is that what I had? Of 3 theta. Okay. everybody get your calculator out and check to see if it's in degree mode right now. I'm going to have to go to degree mode. We're going to be graphing this by hand, but I'm going to let you guys put the numbers into the calculator. What I want you to do is make an XY table somewhere. Now, you can make it on the side of your piece of graph paper if you want, somewhere, or you can make it in your notes. I don't care where. And we're going to start off with 0 degrees, and we are going to go every 10 degrees. Clear to 360 degrees. Well, you'll see a pattern after a while, okay? This one right here is not a clear pattern all the way, so you're going to probably have to put most of them in. You can probably start skipping and go every 20 degrees after a little while, you guys, but at first I want you to go every 10 degrees, okay? So this is what we're going to do. Go back to your home screen now. And we're going to start off with 0 degrees. So you're going to put in your calculator 6 times the sine of 3 times 0, because we're going to 0 degrees first. Hit enter. And you get 0. So we have 0, 0. You're going to go to your pole, and you're going to put 0, 0. That's where you're starting at, right? Okay, then you're going to, did you guys know that if you hit second and enter, it'll bring up the last problem you did? And you can just go back and change that to 10. Six sine of 3 times 10 degrees, because we're going 10 next, right? When theta is 10, what is r? Oh, wait, why did I put x comma y? Why didn't you guys say something to me? I'm getting confusing today. I know. Sorry. All right. R and theta. R and theta. Theta was supposed to be 0, 10, 20, 30, 40, 50. Yeah, you can. There's no sense in rewriting it. Okay, you should have said something. If you have an inkling that I might be wrong, go ahead and mention it. I might be wrong. Okay. Sometimes I'm so used to doing x comma y that I forgot. Okay, now we go right here to r, and we put in, when we put in 0, we got 0. When we put in 10, we got 3. So we're going to go to 10 degrees line. We're going to go to the 10 degree line and go out to 3. 10 degree line, 1, 2, 3 is about right here for me. And you're going to connect them like that. Hit second and enter. Go back and change that to 20. And you get 5.2. Round to the nearest tenth. 5.2. So you're going to go to the 20 degree line and go out to 5.2. Somewhere right around in there. So now you're going to connect that one to that one. Why does that not look right to me? All right. Now we're going to go put in 30 degrees. And if you go to 30 degrees, you get 6. So I get 6, comma 30. So I'm going to go to the 30-degree line and go out to 6, and I have another point right here. So now I have this right here. Okay? And then you keep doing that. Do you guys get the idea? So if I put 40 degrees in, I get 5.2 again. Some of these numbers just start repeating. So I'm going to go to the 40-degree line and 5.2. And I'm going to connect those. Oh, whoops. And then I'm going to get 3 when I put in 50 degrees. I get 3. So that's a 45-degree line. 1, 2, 3. It'll be about right there. I'm going to connect it to there. And I'm going to continue doing that. Now, you're going to get negative R values sometimes, you guys. Don't forget to go in the opposite direction when you get a negative R value, okay? Yeah, you're going to go in the opposite direction of 70 degrees. Is 70 degrees where you get the negative R value? So what is it? 70, what is it? The R value is what? So negative 3 comma 70 degrees. So you're going to go in the opposite direction of 70 degrees, 3 units out, right? Yeah. Okay? All right. Have at it.